Okay, so we're going to investigate a really interesting phenomenon. I have a circuit set up here with a resistor. This is a 1K resistor and a 2200 microfarad capacitor. And in between I have an LED, which is going to show current flowing through the circuit. And so as soon as I turn the circuit on, I want you to notice what happens with the LED and what that indicates. The LED turns on. Hey, we've got current. Yippee! Except that some very interesting thing happens, and that is that over a fairly short amount of time, the current drops down and ultimately it drops to zero. So that's an interesting thing, and we wonder what's causing that exactly. And furthermore, we can play with it a little bit by discharging the capacitor like so. Yeah. Well, sometimes on good days we can discharge the capacitor. There we go. And as soon as we do, the LED lights up again and then goes out again. And so we wonder what exactly is going on with this. To investigate it a little bit more thoroughly, I'm going to turn the circuit off here, and I'm going to replace the 1K resistor with a 10K resistor. At least I'm going to try to. And, wow. That was poorly done. Excuse me. There. Much better. And now, we'll discharge the capacitor one more time. Hoping for a good spark here. There we go. That's a good spark. And now, when I turn this on again, the LED comes on as before. And so we wonder, can we measure what's happening? And let's do that with a voltmeter. And specifically, I'm going to take and measure the voltage drop across the capacitor as a function of time. So let's, Austin, if you'll hold the voltmeter in the camera view here. When I measure the voltage drop across the capacitor, I want you to observe what's happening with the values. And you should be able to observe that the values are going up. And right now it looks like they're going up by about 0.04 volts or so every cycle. It's continuing to climb, and as it continues to climb, notice that our rate of change appears to be decreasing by a little bit, so that now it's only going up by about 0.03 volts every refresh cycle. And as that happens, as the voltage on the capacitor climbs, take a look at the LED. We're getting less current through the LED, as evidenced by the dimmer light. Now we're up to 9 volts, and we're only going up by about 0.02 volts every refresh cycle. And this continues to climb. Now we're going up by about 0.01 volts every refresh cycle. Since my power supply is 13.86, I expect that I'm going to probably cap out, well, I have to cap out somewhere below 13.86. But it looks like at some point it's going to get to be so slow that it will essentially stop or come close to stopping. Meanwhile, take a look at the LED. It's just barely putting out any light at all. And so our purpose is going to be to investigate this phenomenon using Kirchhoff's laws and using what we know about capacitors and resistors.